All right, so transformation 2. So this is how I started, and I actually said, I'm going to repeat something I said. I said that there's a build up to this topic, and what we have to do is I'm going to say some things and show that they are true, and then show you how it applies to the topic. All right, so number 1 says, when the identity matrix, and this is something that everybody should know already, is applied to a point, the point is unchanged. So the identity matrix is 1, 0, 0, 1. Now to apply the identity matrix to a point, we're going to simply multiply the point expressed as a column matrix by the identity matrix. All right. All right, example 1. Example 1 says, show that when the identity matrix I is applied to the point A, which is 2, 3, the result is 2, 3. So as I said, I'm going to make a series of statements, show that the thing is true, ask you to do the same, and then I'm going to tie it in with the objective of the lesson. So what we want to show here is that if we multiply I, which is 1, 0, 0, 1, by A, now A is the point 2, 3. What we're showing is that when I multiply I by A, I'm going to end up back with A. So we're multiplying 2 matrices. We're going to multiply what? Row by a column. There are 2 rows in the first matrix and just 1 column in the second matrix. A is a column matrix. So we're going to multiply. If I multiply a 2 by 2 matrix by a 2 by 1 matrix, I'm going to end up with another 2 by 1 matrix. So first element in the row, first element in the column, second element in the row, second element in the column. All right. So it's 1 times 2, which is what? 2, plus 0 times 3, which is 0. Then I move to the bottom row and the same column. 0 times 2 is 0, and 1 times 3 is 3. So what I end up with is 2, 3, which is the same A, which is what? 2, 3. So this is showing that if I multiply a matrix, if I multiply the coordinates of a point expressed as a column matrix by the identity matrix, I'm going to end up back with the coordinates of the point. So the point that we made earlier is that if you multiply the I matrix, or if the I matrix is applied to the coordinates of a point, the coordinate is what? Unchanged. All right, so what I want you to do is, I want you to do the same thing I just did with A with B. So the next part of the thing says, do the same with B. I want you to multiply I by B and to show that you're going to end up back with B. All right, can everybody try that now, please? All right, so let's do the same thing with the point B. And the point we're trying to make here is that if we apply the I matrix, which is 1, 0, 0, 1, to the coordinates of a point, like say B, which is 3 minus 2, we should get back B. We're going to multiply the first, we're multiplying 2 matrices. So multiply the first element in the row by the first element in the column, and the second element in the row by the second element in the column. So it's 1 times 3, which is 3, and 0 times minus 2, which is 0. Then go to the bottom row, 0 times 3 is 0, and 1 times minus 2 is minus 2. So we're going to end up back with what? 3 minus 2, all right, which is B. So the first point is this. If we apply the I matrix to a point, we're going to get back the point. So if we apply the I matrix to the coordinates of a point, we're going to get back that point. Let's turn the page. All right, second, now this matrix is slightly different from the I matrix. The I matrix is this, the I matrix is 1, 0, 0, 1. You can see that the difference in this matrix is that this matrix didn't start with 1, it started with 0. So there are 4 elements in the matrix. 2 of the elements are 0 and 2 are 1s. All right, the difference between this and the I matrix is that the first element in this matrix is 0. Now, this matrix is what I call the interchange matrix. I don't know if it having that name, but that's what me call it. I call it the interchange matrix. And this says when the interchange matrix is applied to the coordinates of a point, the x and y coordinates will interchange. So all that means is that the x and y coordinates, they're going to what? Switch around. That's what it means. All right. So I'll come back to this to give you a chance to write it off. But let me just do the example. Then I'll come back to it to give you a chance to write it off. Now, example 2 says, show that when the interchange matrix 0, 1, 1, 0 is applied to the point A, which is what? 2, 3, the result is the point A prime, which is 3, 2. So to show that we have the interchange matrix 1, 0, 1, 0, 1, 0, 0, 1, 1, 0. The interchange matrix I'm going to apply to A, which is the point 3, 2. All right. So multiply what? Row by a column, the rows of the first matrix by the columns in the second matrix. First element in the row by the first element in the column. So 0 times 3 is 0. And then 1 times 2 is 2. Move to the bottom row. 1 times 3 is 3. And 0 times 2 is 0. So what we end up with is 2, 3. So when the interchange matrix is applied to the point A, which is what? 3, 2, it becomes A prime, which is the point 2, 3. So again, when the interchange matrix is applied to a point, the x and y coordinates interchange, they switch around. X becomes y and y becomes x. Now I want you to do the same with the point P. I want you to apply the interchange matrix to the point P to see if you get the same results. All right, so now I'm going to do the same thing with P. I'm going to apply the interchange matrix to P. This is 0, 1, 1, 0. Apply it to P, which is the point -2, 5. All right. Now, the point that I'm going to get, I'm going to call it P prime. I'm going to multiply the rows of the first matrix by the columns in the second matrix. How do I multiply a row by a column? First element in the row by the first element in the column. The second element in the row by the second element in the column. So it's 0 times -2, 1 times 5. All right. So we have what? 0 times -2, which is 0. 1 times 5, which is 5. All right. Then we're going to move to the bottom row, same column. 1, 1, 2, 2. First element in the row by the first element in the column. Second element in the row by the second element in the column. So we're going to have 1 times -2 and 0 times 5. So 1 times -2 is -2 and 0 times 5 is 0. So what we end up with is P prime, which is 5 minus 2. So P prime is the point 5 minus 2. And please note that the x and y coordinates interchange. So the second activity was just to show that when the interchange matrix is applied to a point, the x and y coordinates interchange. So the I matrix does nothing. If I matrix is applied to A, you're going to get back A. The interchange matrix, however, it switches around the coordinates. X become y and y become x. Let's move on to the next page. Now, this says the top row of a matrix influences the x coordinate of a point, and the bottom row influences the y coordinate. I'll say that again. The top row of a matrix influences the x coordinate and of a point, and the bottom row influences the y coordinate. 6, I'll get back to it so you can write. 6 says, 6 is the I matrix. The I matrix, so when the I matrix is applied to a point, the point is unchanged. Now, if you change the 1 to -1 in the top row, this changes the sign of the x coordinate. And if you change the sign of the y in the bottom row, it changes the sign of the y coordinate. So what I'm going to do is I'm going to apply this matrix here to A to see what happens. Now I'm saying to you, based on the theory, when I apply this to A, the sign of the x coordinate is going to change. Let's change the color. So 1, 1, 2, 2. So it's the I matrix. Your starting point is the I matrix. 1, 0, 0, 1. This top one influences the x coordinate, and this bottom one influences the y coordinate. If you put a negative here, all that is going to do is, in effect, is to change the sign of the x coordinate. All right, let's see if that is true. So first element in the column times the first element in the row times the first element in the column. So that's -1 times 2, which is -2. Then second element in the row, 0. By the second element in the column, 3, you get what? 0. 0 times 3 is 0. Bottom row, first element in the row, 0 times 2 is 0. And the second element in the row, 1 times the second element in the column, 3. 1 times 3 is 3. So what I'm going to end up with is, I'm going to end up with -2, 3. Proving the fact, and this is A prime, which is what? -2, 3. So if I apply this matrix here, what happens is that it's going to change the sign of the x coordinate. The bottom one should change the sign of the y coordinate. I need for you to do the bottom one before read 7 to show that when you apply that matrix to A, it's going to change the sign of the y coordinate. Do that now, please. All right, so next we're going to apply this other version of the I matrix to A. As we said, our starting point was I. This is I. If I apply the I matrix to the coordinates of a point, the coordinates would be unchanged. If I apply the I matrix to the coordinates of a point, the coordinates would be unchanged. If I just simply change this one to negative, if I change this one to negative, it's going to change the sign of the y coordinate. If both of them are negative, it would change the sign of both the x coordinate and the y coordinate. All right, so what we're going to show is that if I change the sign of the bottom one, it is going to change the sign of the y coordinate. All right, so let's do that now. So first element in the row, first element in the column, second element in the row, second element in the column. First matrix by the columns in the second matrix. How do we multiply a row by a column? First element in the row by the first element in the column. So it's 0 times 2, which is what? 0. All right. All right. Nobody saw it, but let me change this. They made an error here. We're using the wrong matrix. Which is the matrix you should be using? It's 1, 0, 0, -1. I want to show that that matrix, what it does, all it does is change the sign of the x coordinate. So it's 1 times 0. 0 times 2 is what? 0. -1 times 3 is -3. So this becomes the point 2 minus 3. So this becomes A prime, which is 2 minus 3. All right. All right. All right, so next, let's look at the last part here of the lesson. All right, so at 7, we have 0, 1, 1, 0. This is the interchange matrix. And what the interchange matrix does to a point is that it interchanges the x and y coordinates. So x become y and y become x. Now, if I put a negative at the one at the top, it interchanges the x and y coordinate and changes the sign of the new x coordinate. If I put a -1 at the bottom, this would interchange the x and y coordinates and change the sign of the new y coordinate. All right. And of course, if I put negative at both the top and the bottom, it would both interchange the x and y coordinates and change their signs. So again, the interchange matrix 0, 1, 1, 0. This interchanges the x and y coordinate of a point, switches them around. If I put a -1 here at the top, what it does is that interchange the x and y coordinate, but change the sign of the new x coordinate. If I put the -1 at the bottom down there, what it would do is it would interchange the x and y coordinate and also change the sign of the new y coordinate. So let us show you this entire thing in action now. All right, so I'm going to do the top one, you're going to do the bottom one. And what we're going to show is that the coordinate of the resulting points, the x and y coordinates are going to interchange, and the sign of the new x coordinate is going to change. Zero times 2 is 0. -1 times 3 is -3. 1 times 2 is 2, and 0 times 3 is 3. All right, so what we're going to end up with is -3 at the top. Sorry, this should be 0 here. 0 times 3 is 0. And at the bottom, we're going to have 2. And so what we're going to get is a prime, which is -3, 2. The x and y coordinates interchange, and the sign of the new x coordinates. Apply the bottom matrix to A and tell me what you get. All right, so we're applying this matrix to the matrix A. And what we want to show is that when this matrix is applied to A, it's going to interchange the x and y coordinates and change the sign of the new y coordinate. 0 times 2 is 0. 1 times 3 is what? 3. So that brings the 3 at the top. The 3 is at the bottom is now at the top. Then -1 times 2 is -2. So now the 2 goes to the bottom and its signs change. And 0 times 3 is 0. And so what we have now is we have A prime, which is the point 3 minus 2. So this gives you A prime, which is 3 minus 2. What do I observe? So A, which is 2, 3, became 3 minus 2. So the x and y coordinates interchange, and the sign of the new y coordinate changes. the X and Y coordinate interchange and the sign of the new Y coordinate changes. All right, so that's the first part of the lesson. Now, the next part of the lesson, we're going to show you how this entire thing ties in.